Hey guys, here we go with our 9.02 lesson. We're going to be talking about theoretical probability, what we did yesterday, versus our new topic, which is relative frequency. So for our investigation, we're going to conduct an experiment by flipping a coin 10 times and recording our results. First, we're going to calculate some theoretical probabilities. First thing we need to know is the sample space for flipping a coin. For sample space, I just need to remember I'm going to list all possible outcomes. I have heads and I have tails. Those are the only two things that could happen when I flip a coin. I don't know why I had a red pen, guys, sorry. So the probability of landing on each outcome, we're going to write as a fraction and as a percent. So probability of heads, there's only one side with heads and two total sides. So 1/2, aka 50%. Probability of tails, same thing. This is the theoretical probability, remember, that we talked about yesterday. I'm just making a fraction based on what I know. So now I'm going to actually conduct my experiment 10 times. So let's say you can pause your video, flip your coin 10 times, tally your results. Let's say these are my results. I got 6 heads and 4 tails. So based on my experiment, I got heads 6 times out of my 10 flips. So I have 6/10. We can think of that as 60 out of 100 or 60%. I got tails 4 out of the 10 times. Again, 4 out of 10 is like 40 out of 100, so 40%. So the question is this: is the theoretical probability the same as my results? And it looks like they were different. And I want you guys to pause and fill in why you think that is. After you've written your response, you can check it. Basically, the reason these are different is because one was a prediction and one is an actual test or an experiment. One is a prediction and one is an experiment. And you can actually put that, if you had something different for that answer above, you can go ahead and put this explanation in your stop and jot. Observed relative frequency is like an experiment. You actually do something and you record your results. Theoretical probability is a prediction. You're making a prediction based on what you know about your situation. So let's see another example. Imagine you're given a bag with 4 pieces of paper. You decide to conduct an experiment where you draw a piece of paper from the bag. You do this 20 times and you get these results. So we're going to find the theoretical probability and the observed relative frequency of each outcome, and we're going to find it in a fraction and a percent. So first, for our theoretical probability, remember this is their prediction. So how many are there of the color you want and how many are there total? So we know that our bag has 4 pieces of paper, and it looks like our results are red, blue, yellow, and green. So we can predict that the theoretical probability of red is 1 out of 4. Which is, think about quarters, 25%. Same for blue, same for yellow, same for green. I'm predicting that they're all the same because all I know about them is that there are 4 pieces of paper in the bag and they're 4 different colors. Now my observed relative frequency, we're gonna look at our data. How many times did I actually get that thing versus how many times did I do my experiment? So for red, again, if you look up top, we can see red is at 5, and my total is 20. So 5 over 20, we're going to have to simplify. If we divide both of those by 5, we actually do get the same as our theoretical, so 25%. Blue, we have 4 out of 20. Again, we have to simplify, divide by 4. We get 1/5, which is like 20%. For yellow, we had 7 out of 20. This one's a little more difficult to make a percent, so what you can think about is 7 out of 20 equals x out of 100. I can see that 20 times 5 is 100, and 7 times 5 is 35. So this is actually 35%. And then last but not least, green is 4 out of 20. Oh my gosh, it matches blue, so we have 20%. So again, I want you guys to notice the observed relative frequency. If I look here, it's the same. Here, it's different, different, different. So it's not necessarily that they're going to match. So for our key points for today, our first one with our new vocab, we have observed relative frequency. It's similar to theoretical probability in that it can still be expressed as a fraction or a percent to show how often things happen. Just like the other one, our numerator is the amount of times an event happens. So how often did something occur? And the denominator is the amount of trials you did, just like we just showed in our guided. So let's keep going with our guided question. We're going to conduct a new experiment and try to get more trials. So our theoretical probability hasn't changed. We're still doing the same situation. So we have 1/4, 25%, 1/4, 25%, 1/4, 25%. That's still our prediction. But now our observed relative frequency, you guys can see these numbers are a lot bigger. So red, I can see I got 197 times. I wasn't given the total, so I'm going to have to find the total number of times by adding up all of my trials. I just took the numbers that I had circled over here, and we're going to add these up. If you want to use a calculator, you can go ahead and do that. But basically, I like to do 7 and 5 is 12, and 8 is 20, 2 and 9 is 11, and 9 is 20, and then 2, 3, 5, 6, 8. So I have 800 trials. So 197 out of 800. Now, again, we're working with big numbers here. So again, you can grab a calculator and do 197 divided by 800. Give me a second to get my calculator going. And let's see if you guys, I can get this so you can see it. All right, 197 divided by 800 is I lost my number, 0.24625. So if I want to make this a percent, remember, take this decimal, double swoop. That's like multiplying by 100. Remember, percent's 100. So this is 24.6%. Next one for blue, we have 205 out of 800. Grab a calculator. 205 out of 800. 0.256, so I'm going to call that 25.6%. And then we move a little faster through these. 190 out of 800, 23.7%. And then last one, 208 out of 800. Oops. 26%. So what I want you guys to notice is how close these numbers got to 25. So 24.6 compared to 25, 25.6 compared to 25, 23.7 and 26. Got a lot closer than where we were before. Before we had 25, 20, 35, and 20. Those were further away than these trials down here. So this is a really cool thing called the law of large numbers. And basically, this is our second key point, so you guys are going to have to skip down a little bit in your packet to find this. But basically, the law of large numbers states that the larger the number of trials, remember, trials is just when you do the experiment, so the higher the number of times you do an experiment, the larger number of trials in an experiment, the closer the observed relative frequency gets to the theoretical probability. And if we look back, that's just what we saw. Our observed relative frequency was closer to our theoretical probability when we had more trials. Here we had 800 trials than the first time where we only had 20 trials. Pretty cool. So now you guys should be able to go back into your stop and jot. I'm sorry, I'm kind of bouncing around. But I want you to think about what we just talked about and describe what is the difference between the first and second experiments. After you do that, you are ready to continue the rest of this packet. Do your best. Good luck.